Hello everyone, it's August the 7th. Alright, let's do this. Count vowels permutation. Given an integer, your task is to count how many strings of length n can be formed under the following rules. Each character is a lowercase vowel. Each A may only be followed by an E. Each E may only be followed by an A or an I. Each I may not be followed by another I. Each O may only be followed by I or a U, and each U may only be followed by an A. So we want to find how many strings of length n can be formed under the following rules. Okay. Each A may only be followed by an E, so A either not following or only followed by one, so which means A can only be at the end, or A must be followed by an E. E may only be followed by an A, so E or EA or EI. I may not be followed by another I, so it cannot be II. O may only be followed by an I, so O can only be followed by an I or a U, OI or OU. U may only be followed by an A, so that is actually U may only be followed by, so U is UA or U by itself. So everything can end, right? Everything can end by itself, but if it don't end, that's the rule. So A can only be followed by E, U can only be followed by A, and E can be followed by A or I, O can only be followed by I or U, and I may not be followed by another I. So if I want to make 2, a length of 2, right, then we can say if it starts with A, how many do I have? Which starts with E. How many we have? I, O, and U. How many we have? And then if we start with A, then we need to find how many we start with E. If we start with E, then how many we start with A, and how many we start with I. With I, how many we start with A, E, O, U. And then with O, it's going to be I and U. With U, it's just going to be A. And those are start with 1, right? So E start with 1, we have AE. We have EA and EI, start with 1. I, we have IA, IE, IO, and IU. O, we have OI and OU. And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. Okay. So what we can do is, well, we start with certain character, and we have these rules. And then basically, for each character, for each letter, we have a rule of how many we can do, right? And then we just go there. And maybe what we can do, we can build bottom up, right? We say AEIOU is all the columns, right? So we have AEIOU. If we have 1, n equals 1, n from 1, right? If we have 1, then the number we can form is going to be 1. If I have 2, right, then we start with A, and then A can only go to E, so let's only have 1. If it's E, we can start with A or I, so that's 2. If it's I, we can start with A, E, O, U, so that's 4. If it's O, we can start with that's 2. If it's U, it's going to be 1. So that's 1, 2, 4, 2, 1, which gives me 10. So if we start with 3, right, from A, I can only go E start with 2. So that's 2. From E, I can start with A and I, so I look for A and I, that's 5. For I, that's just 1 plus 2 plus 2 plus 1. 1, 2, 3, 4, 5, 6. O is I and U, which is 5, and U is A, which is 1. So A is E, U is A, U is 1, so that's 3. 4, A is E, so 4 is going to be 5, right? E is, that's 8, this one 10, 5, 5, that's 13. O is IU, that's 7, and then U will equal to A, which is 2, 5. So 8, and then we add these two together. That's 18. This will add everything together. That's 10, 15, 22. This adds these two together, 15. This will equal to this, so 5. So for n equal 5, we shall have 8 plus 18 plus 22 plus 15 plus 5, which gives us 68. So I do believe that is how it is. But the thing is, we have so many. Do we have an easier way to do? Well, A and E are exactly the same, right? And then U and A are exactly the same, which means we don't have to compute those two. So for each one, I need to compute this, the sum of these two, the sum of these two, okay? Do I have a... trying to see if there's a pattern so we can like figure it out faster. Then I need two arrays, right? There's gotta be a way to do it faster. So I know this is going to be 18. Right? This needs to be these two plus together. I honestly don't know if there's any faster way. I mean, I feel the slow way will work, but I'm pretty sure there is a faster way to handle this. But we need 2, because we cannot just use 1. It changes, it requires the sum of the previous ones. So we say dp equals 1, 1, 1, 1, 1, 1, 2, 3, 4, 5. And then we say for this in range 2 to n, n plus 1, right? And the rest equals, actually we don't have to do rest at the moment. When I say temp equals, actually we can just say dp equals something, right? So that will be dp1. This is dp0 plus dp012. And this is sum dp minus dp012 and dp2 plus dp3, 1, 2, 3, and the last one will equal to dp0. And now I'm going to return sum dp mod so have 1 is 5, 2 is 10, 5 is 68. How? Did I overdo it? I gotta take a look. Maybe we do it too much, or so that's 2, 3, 4. Oh, the 5 is different. Oh, this one's different. This one is different. This is 6. How is it 6? It's supposed to 4 plus 1 should be 5. What the hell? Oh, dp2 plus dp4. Oh, my bad. It was just a mistake. Yeah, I'm not sure. I mean, just submit. Yeah. So I wonder previous, 92 milliseconds. So this is a naive solution. So naive DP solution. O5N. $43. Oh, I didn't check the test cases. Probably the same test cases. Yeah, it's the same. So what make this one so fast? Matrix power. Oof. This is a matrix power. multiple ones. Oh, matrix power. Yeah. Not in mind for this, but very interesting. Matrix power. Okay, so that one's done. Do we want to do this? No, I don't want to do this. Alright, I'll see you guys later today. Adios.